In this presentation, we will learn how to plot the velocity and time in a graph. In the previous videos, we learned how to plot the distance and time in a graph. So when we plot the distance and time in a graph, we will get an idea about the speed of the moving vehicle, right? But here, instead of the distance in the y-axis, we have the data speed which has to be plotted in the y-axis, and as usual the x-axis should have the time. So the time is plotted in the x-axis and the speed or velocity, whatever the given data, is plotted in the y-axis, right? So as you see the data with the unit meter per second, which means the speed is specified. So the speed of the vehicle is noted and it is given as a tabular column. So we are asked to plot the point of intersections and get a line. So in this graph, in this line graph, which is obtained by the point of intersection, will help us to know about the rate at which the speed or velocity changes. Now can you tell me what is the term which will be used to refer the rate of change in velocity? Yes, it is acceleration, right? So the rate of change in velocity is nothing but the acceleration. So this graph will enable us to know about the acceleration of a moving body, since we have the speed or velocity which is plotted in the y-axis, right? So in this given data, and 0, 0 are plotted, you will be getting the point here. 0, 0 is nothing but the origin. And the next data we have 1, 0, x coordinate is 1 second and y coordinate is 0 meter per second. So it is 1, 0. So which is again on the x-axis. 0 in the y-axis is nothing but the origin itself. So the data which is 1, 0 has a point of intersection on the x-axis itself. Similarly, 2, 0 is the next coordinates which are given, so which is again plotted here. So 2 in the x-axis, 0 in the y-axis will again be on the same line x-axis. 3, 0 is again on the x-axis, 4, 0 again on the x-axis. So we get a straight line which is on the x-axis itself, which means the object or the bus or the car is at rest because the speed is 0. So as there is increase in the time, there is no change in the speed, it is just 0, which means as acceleration of the moving body is 0. So it has 0 acceleration, and that is why we get a line graph on the x-axis. So the speed remains 0 meter per second. So this is the observation that you can make with the line graph very easily. So with the help of velocity time graph, we will be able to find out the acceleration. So in the previous video, it was the distance which was plotted in the y-axis. Do you remember? So what do you observe? When you plot the distance in the y-axis, you will be able to predict the velocity, or if it is displacement, you will be able to predict the velocity. If it is distance, you will be able to predict the speed of the moving vehicle with the slope of the line that is formed, right? So here it is the acceleration that is going to be found using the line graph. So right, we will move on to the next example. So in this second example, we have a different set of data for another vehicle which is moving with a different speed. So it is again plotted. So the first coordinate 0, 10, 0 is in the x-axis and 10 in the y-axis here. I will mark it, right? And then the next coordinates are 1, 10, right? It is here 1, 10. So it is plotted here 1, 10, right? Similarly, the next 2, 10. So 2, 10 is again on the same horizontal line. Then 3, 10 is the next coordinate. X coordinate is 3, y coordinate is again the same 10. So all these coordinates are plotted, the point of intersection obtained are joined, and we get a straight line which is parallel to the x-axis. So we know already if we get a straight line parallel to the x-axis, the slope of the line is 0, which means the acceleration is 0. So here, as I told you in the earlier slide, if it is the speed which is plotted in the y-axis, right, and time in the x-axis, this speed versus time will help us to know about the change in the speed with respect to time. That is, the idea of acceleration will be obtained through this graph. So as you get the slope of this line which is 0, that is which is parallel to x-axis, which means there is 0 acceleration, that the body is moving with a uniform speed, as you can very well see from the data. So the speed is constant, which means it has no acceleration. There is no change in the speed of the moving vehicle, provided the direction is also same, then we can say that the body is not accelerating. So acceleration is 0, as you can very well see that the slope of this line, the slant of this line is 0, right? The third case, as we plot 0, 10, so it's a wrong data, so it is actually 0, 0. So the first second it is at rest. Then after 1 second it has reached the velocity of the speed is 10 meter per second is plotted. So then the next data is 2, 20, 3, 30, 4, 40 are plotted, and we get a line which has a constant slope, that is a constant gradient. Gradient is nothing but the slope, right? So the slope of line is constant, which means the object has a uniform acceleration. That is, when you find the slope of this line, now let us find the slope of this line. So this dot has the x coordinate 5, right, and the y coordinate 5, 50, right, 5, 50. Similarly, here we will take a point, the next point on the line, which is 1, 10, right? It is 1, 10. So we know how to find the slope of this line. So it is y2 minus y1 divided by x2 minus x1. So y2 is 50 and y1 is 10. So 50 minus 10 is 40. Am I right? Divided by x2 minus x1. 5 minus 1 is 4, right? So 40 by 4 is 10 meter per second by second. So this is meter per second. Again by second will give you 10 meter per second squared. So acceleration is 10 meter per second squared. That is the slope of this line is 10. So which means the acceleration is 10 meter per second squared. So it has a constant acceleration, and that is why we get a slope, the line with a slope with a constant slope. So this is the observation that you can make. So as you see in this, the speed of the car increases by 10 meter per second every second. That is why we get 10 meter per second square as the acceleration of the moving body, right? Similarly, we will move on to the next example where we have the data. So here, as you see, first it was 50 meter per second, then it is 40, then it is 30, then it is 20. So it is gradually decreasing, which means it has a constant decrease in the velocity. So there is a uniform deceleration. Now let us find the slope of this line. So now here the coordinates are 0, 50, right? Any 2 points we'll just take and find the slope of this. We will be getting a negative slope. Now here we'll take this point 4, 10, right? 4, 10. Now what is the formula to find the slope? y2 minus y1. y2 is 10. 10 minus 50. y2 minus y1. So this 0, 50 is x1, y1. 4, 10 is x2, y2. So y2 minus y1, I'll write this 10 properly. y2 minus y1, 10 minus 50 is minus 40. Should know that 10 minus 50 is minus 40 divided by x2 minus x1 is 4 minus 0, which is 4. So what is the answer? Minus 40 by 4 will give you the answer minus 10 meter per second. Again by second will give you 10 meter per second square. So the acceleration is minus. So we already know if you get an answer, the acceleration equal to minus. If you get an answer in minus, then it is negative acceleration, which is also called as deceleration. So we are getting a constant negative slope, a slope with a negative slope which is constant, uniform throughout, which means it has a uniform deceleration. Just like the deceleration due to gravity, you have a decreasing slope, which means the acceleration is constant, that is deceleration is constant. So this line has got a negative slope, and that too it is a uniform motion, and there is a decrease in velocity for every second is 10 meter per second. So the speed of the car decreases by 10 meter per second every second. The next example, we have the bus traveling with an increasing acceleration. That is, you will be able to see very well with this graph. You have a increasing speed with time. So the graph has a positive and increasing gradient, and towards the end of this, you see in this time graph from 4 to 5, I'm not able to draw properly, but just observe 4 to 5, you have more distance covered. When you join the y coordinate, you will be able to see easily. More distance is covered in less time gap, which means it has got an increasing acceleration. So the acceleration at every instant can be found by drawing a tangent at that point. At that point, you can just draw a tangent and find the slope of that, which you will learn in higher classes in detail. So this graph says that there is an increasing acceleration and the object is moving with an increasing speed. Similarly, the next graph, the acceleration is decreasing because we have within 4 to 5, the distance covered is very less. So when you just consider these 2 points, 4 to 5 seconds, the distance covered is very minimum, which means the car or the bus has got a decreasing speed towards the journey. So the decreasing slope at the end shows that it has got a decreasing acceleration, right? So this is how we can easily predict with the velocity time graph or speed time graphs. So these are the observations that you can make. So in the velocity time graph, if you get a straight line parallel to the x-axis, then it means it has got a constant velocity. Similarly, when you have a slope with a constant gradient, right, it means it has got a constant acceleration. Similarly, the same line but in the reverse side, it means it is a constant deceleration, that is uniform deceleration, uniform acceleration. Here it is uniform acceleration, and here it is uniform deceleration, right? Constant deceleration. Again, when it comes here, it is at rest, and again there is an increase in the speed, that is in the opposite direction, acceleration in the opposite direction, and that is why it is there in the other coordinate. So this you will learn in your higher classes in detail. So these are the 3 observations that is very important for you to understand. So we'll just recall these 3 graphs. In the distance time graph, so this is a very important question which you may go wrong. The distance time graph, if you get a straight line parallel to the x-axis, that is slope is 0, which means the object is at rest, right? There is no doubt. So the object is at rest. It is because it is a distance time graph where the object is not moving. But in the case of the next case, the speed time graph, only if you get a line on the x-axis, that is there is no speed, that is 0 is the speed constantly after as the time increases. Here the speed and time graph, if you get a straight line on the x-axis itself, then you can say that the object is at rest, right? The object is at rest. And then the third case, the straight line in the case of speed and time graph, if you get a straight line, horizontal line parallel to the x-axis, then the slope is 0. Then here, what does it mean? The object is not at rest. The object is moving with a uniform speed, that is acceleration is 0. So you may often confuse the distance time graph. If you get a slope 0, a line with a slope 0, then the object is at rest. In the speed time graph, if you get an horizontal line with a slope 0 parallel to x-axis, then the acceleration is 0. There is 0 acceleration. That is, it is moving with a uniform velocity. So this is often confused by the students. Please make a note. Hope you followed. So this concept you will learn again in class 9. It is just an introduction. You need not worry. It is enough if you learn the basics of it. They will not ask you to plot the graph. They will just ask you to see the graph and record or ask you for the inference. Hope you followed. We will discuss with few more examples in the future classes. Thank you.